Hi there, welcome to my video on integration by parts. So before with integration, we kind of learned our power rule, our substitution rule, a couple kind of methods of integration. Integration by parts is just another tool you can add to your kind of toolkit with finding integrals and evaluating them. So instead of starting with integration, I'm going to start with differentiation because that is where the formula ultimately comes from. Okay, so if we had, let's say, I'll think of an example here. Let's say we wanted to find the integral of x times e to the x with respect to x. So x times e to the x dx. This is what we're trying to figure out. Okay, so the first thing we always look for is if it fits our table. Okay, so can we use the power rule? Are there any kind of rules that we know where if we have the product of x and e to the x multiplying together, can we integrate that? And the answer is going to be no. There's no kind of tools that we can use in terms of tables or memorizing where we could evaluate this thing. Okay, so the next thing we think of is, can we use our substitution rule? Okay, so no matter what you call u, you could call it e to the x, you could call it x, doesn't matter, you're not going to be able to figure this out with substitution. So we need another tool to be able to figure this out because we're not just going to give up there, right? There is a way to solve this. So I'm going to show you where integration by parts comes from. Okay, so if you remember back to differentiation, when we had the product of two things, let's call it f of x and g of x, right? If we want to take the derivative of this whole thing, right, two functions multiplying together, okay, I'm going to move this over a little bit here. If we want to take the derivative of this whole thing, we had to take f prime of x times g of x, right? And this was a sum. We had to add f of x times g prime of x, right? So we couldn't just distribute this prime factor into both of the functions. It's not going to be f prime of x times g prime of x. It followed this specific formula, right? So what if we wanted to integrate something like f of x times g of x dx? That's a sloppy integral, but if we wanted to integrate two things that were multiplying together that didn't fit our table, or we couldn't substitute it, right? So integration by parts just says, well, we can look at this entire thing and let's just integrate both sides. Because if this left side here, we're integrating that, or sorry, we're differentiating it. The inverse operation of differentiation is just integration. So if we integrate the left side, we're just left with f of x times g of x. Okay, and if we integrate one side, we have to integrate both sides. So I'm just going to squeeze a dx in there. Okay, I'm going to squeeze a dx in there. Integrate this side. We got to add our dx because it's with respect to x. Okay, so if we integrate every single term here, right? If we integrate every single term, on the left, we're just left with f of x times g of x. Okay, and we can worry about a plus c later. Okay, so f of x times g of x, that's going to equal the integral of whatever f prime of x is, right, times g of x dx, and we're going to add the integral of f of x times g prime of x dx. Okay, in integration by parts, we just rearrange this formula. Okay, so what we do is we subtract this integral from both sides. So if we subtract f prime of x, g of x on both sides, right, we do it on one side, we have to do it to the other, minus, sorry, the integral f prime of x, gx dx. Okay, what we're left with, this guy's going to cancel out. Okay, so what we're left with is, I'm going to write this term on the right, on the left now, just for simplicity reasons here. So f of x times g prime of x dx, that's going to equal our left side here. So that's going to equal the two functions originally multiplying together, f of x times g of x, right? And then we subtracted that integral f prime of x g of x dx. So this is technically your formula for integration by parts, but what we did was we just made it look a little nicer. So instead of using like f of x, g of x, g prime of x, all this is pretty ugly. All we did was we just let u equal f of x. Okay, so if u is f of x, then du by dx is f prime of x. So that means du is going to be f prime of x dx. Okay, and we use u for f, and for g we're going to use v. So u and v are kind of the standard letters that we use here. So if we know that v is going to be g of x, right, that means that dv is going to be g prime of x dx. Okay, so to kind of rearrange this formula, all we do is we plug in these letters where we see its corresponding kind of value. So wherever we see f of x, we're going to plug in u because that's what we're calling f of x. Okay, so for the original left side here, the integral of f of x times g prime of x dx, this is going to be u, that's going to be your f of x, and then g prime of x dx, that's just over here, so that's going to be our dv. Okay, so the integral of u dv, that's going to equal f of x times g of x, so that's just u times v. Okay, I'm going to make that look a little neater. U times v, right? And then, see up here, we're subtracting this entire integral. So we're subtracting the integral of f prime of x gx dx. Yeah, f prime of x gx dx. So g of x is v. So I'm going to bring that to the front. I don't know why my pen's acting all weird. I'm going to bring that to the front. And we're left with f prime of x times dx. F prime of x times dx is just du. Okay, so this is what we're left with. The integral of u dv equals uv minus the integral of v du. So see how this is a lot simpler than this up here. Both mean the same thing. It's just I personally like the second one a lot more. Makes me think of the questions as a lot more approachable when I think of things in terms of u and v instead of f of x and g of x. That's just me personally. Okay, but everyone's different, so you can use both ways, but in the next couple videos, we're going to be using this formula here, just because I think it's much simpler. So let's kind of, instead of thinking of things in terms of u and v, let's actually kind of pick a question to do here. So a really basic one that lots of people start out with is the integral of x times e to the x dx. Okay, so this one right here is one that we can't solve using our table, our power rules, or our integration by substitution, but we can solve it using integration by parts. Okay, so you might be thinking, well, how do we choose u and v? Because it's probably going to make a big difference in the way we solve these equations. And you're right, it is. So I kind of thought of an acronym. I saw it online as well that is really helpful. Okay, so it goes L, I, A, T, and E. Liat or Liati, however you want to say it. And each letter stands for, this is going to be logs. Okay, this is going to be your inverse trig. This is going to be your algebraic expressions. This is going to be your trigonometric expressions. This is going to be your exponential expressions. So when you get a question like this, okay, so there's two things multiplying here. There's a product of two things, x and e to the x. Whatever comes first throughout this list, that is going to be our u, because the further to the right you get, so as you start from the left and go to the right, it becomes harder and harder to integrate that. Or pardon me, it becomes easier to integrate it as you move to the right. And as you go to the left, it's more difficult to integrate logarithms and inverse trig functions, okay? And at the same time, you also want to balance where you're able to differentiate that u term, right? Because it's easy to differentiate logs and algebraic expressions. Heck, you could differentiate almost anything you wanted, but integrals are a bit harder. So this is just kind of a system that you can use that I find is super helpful. Okay, so in terms of the order that we should pick it, x, right? That's an algebraic term. So since algebraic comes before e to the x, which is exponential, that x is going to be our u. Okay, so I'm just going to erase this here now that we know the order. And I'll reference this in my other videos. I'll draw it again, but for right now, I'm just going to say let u equal x, right? If u is x, then du is just dx, right? Because the derivative of x is 1, and 1 times dx is just dx. Okay, and if u is x, then we're left with e to the x, right? We're left with e to the x to be part of our v. So as soon as we choose x for u, our v is just going to be whatever's left over. So we can ignore this x right now. Our v is going to be the integral of e to the x dx. See how that's kind of all that's left there? So our v is going to be e to the x dx, and that's just e to the x. So see how we can integrate that? That's because we used our acronym there to help us out. And if v is e to the x, dv is also going to be e to the x, and we have this dx term here. Okay, so once we have that, we can kind of start to plug things in here, right? So let's just go back to our formula. The integral of u dv equals u times v minus the integral, minus the integral of v du. Okay, so our u was x, du is e to the x, dx. This is our original expression. We're integrating that. That's going to be our u times v. So u is x, v is e to the x, or the integral of e to the x dx, which is just e to the x. So that is x times e to the x minus the integral, okay, minus the integral of v du. So what was our v? That was e to the x, du was dx. So minus the integral of e to the x dx. Okay, and now this is something that we can integrate. So we started out with this thing on the left here. We ended up with this on the right, which we can in fact integrate. So we're going to get x times e to the x minus the integral of e to the x dx is just going to be e to the x. So you could leave it as this, and of course we need our plus c. So you could leave it as this. You could factor out the e to the x. Doesn't really matter. Both answers are right. But this is kind of the basic intuition as to what integration by parts does. Is we start with something like the integral of u dv, integral of x times e to the x dx, which we can't quite integrate with the stuff we already know how to do. So we break it up into this formula that we do know how to use. Okay, so instead of integral of u dv, we're hoping that u times v minus the integral of v du is something that we can integrate. And oftentimes it is. It just depends on how you choose u and v. So it's super important you use that chart, right? So the L is logs, I is inverse trig, A is algebraic, T is trigonometric, and E is exponential. So whatever comes first in terms of this list, that's going to be your U. So for this question, X, right, that's algebraic. That comes first before exponential, right? So that was our U. And whatever's left over, that's going to be our V. So this list is super helpful. And once we have everything kind of chosen, we write it in our kind of variable list here, u equals x, du equals dx. It's going to change from question to question, but it's always good to write it out so you don't forget. And at that point, it's just a formula, right? You just plug things in, and hopefully it works right away. And sometimes you need to do integration by parts twice. Or for this integral, even if it's simpler than what you started with, you might have to do some substitution or another integration by parts step there. But this is kind of a basic introduction into what it is, and I hope this helped. The next couple of videos, I'll be kind of diving deeper into how we can solve more complex problems with integration by parts, because it does get pretty messy. But this is a foundation, so I hope this helped, and I'll see you in my next video.